Hello everyone and welcome to another episode of Solving Advent of Code in Rust and Try to Learn Rust in Between. I'm Roberto and we have
Luciano.
Cool. Thank you everybody for following along. If you never did Advent of Code is a code challenge that is published around the Christmas period every year. We're working toward the last year one. There are 24 challenges that you can find on adventofcode.com. We are publishing all our code on a GitHub repository. We have a YouTube channel and we are publishing there all the recording of these lives. You can find the link in the description of the Twitch channel. Last time we did exercise 23, which one, I don't remember what it was about. I just remember that we took a lot of time to finish it. And
totally forgot as well what it was about.
Developers have very good memory, remember that. So probably we have to start to think of another career. So today let's start with exercise 24. And we can start reading the README, the GitHub README. Okay, can I start?
Yes.
Okay, day 24, arithmetic logic unit.
Maybe make it just 1 point bigger.
1 point bigger, like this?
I think it's better, thanks.
Okay, perfect. Magic smoke, there is the usual story. Magic smoke starts leaking from the submarine Alu. Without the ability of performing basic arithmetic and logical function, the submarine can produce a cool pattern on with Christmas lights. Also, it can't navigate or run the oxygen system. Don't worry, you probably have enough oxygen left to give you enough time to build the new ALU. So we have a 4-dimension processing unit. We have integer variable w, x, y, and z. These variables all start with a value of 0. The ALU supports 6 instructions. Imp A, imp something, imp A, read an input value and write it to the variable A. Add A with B, that add value of A and B together and store it in A. Multiply A and B and store in A. Divide A by B, truncate the result to an integer and store the result in a variable A. By truncate, we mean to round toward 0. So if it's negative, it goes towards 0. So, and so on. Mod A and B, that means that you keep the remainder and you store that in A. EQL A and B, if the value A and B are equal, it stores 1 in A, otherwise it stores 0 in A.
Mm-hmm.
Obviously, there is no register A and B. Those A and B are placeholders for W, X, Y, or Z. B can be a variable or a number or an immediate, like they say in assembler. There is no jump instruction because it's an ALU, it's not a CPU. And here there are some examples. So take a number, multiply that by -1, take 2 numbers, multiply Z by 3, and put it back in Z. Is Z equal to X? And put in Z 1 if it's equal, 0 if it's not equal, and so on. What do we have to do? Submarine model number are given in 14-digit number consisting of digits between 1 and 9. 0 cannot appear in the model. This is called a monad, that is a model number automatic detector.
It's not a functional programming monad, so don't worry.
Yeah, exactly. So we have to check these model numbers. So to check a number, we give every figure to an input function. So given this number, it will give 1, that is the first figure, to the first input instruction, 3 to the second input instruction, 5 to the third, and so on. So every time there is an input instruction, from the number that we have to check, we have to take only 1 figure. This means that when operating monad, each input instruction should only ever give an integer value between 1 and 9, because the figures are those.
Mm-hmm.
Then after monad are finished running all of the instruction, that is our input that I will show you in a moment, it will indicate that the model number is valid by leaving a 0 in the variable z. However, if the model number is invalid, it will leave some other non-zero value in z. So we give to this program in this kind of assembly a number, 15 digits number, and we want to have 0 in z at the end of all these instructions. If we don't have 0, it means that the number we gave to the program is not correct, is not a valid monad.
So long story short, if I can summarize,
yeah,
a stupid solution would be, so of course here they're asking us what's the maximum, right, of these numbers?
Part 1 is asking what is the largest model number accepted, and part 2 is the same, but is asking what is the smallest number accepted. So basically they are the same bunch of code and logic. It's just that one wants the max and one wants the min.
Exactly. So if we were to do a very shitty brute force solution, it's like starts from 9999999, run the algorithm. So we'll need to encode somehow this assembly so that it runs against this number and gives us the Z value at the end. And then until we find Z equals 0, we keep going
down.
-1, -1, -1. And we need to be, of course, excluding all the cases where there is a digit 0 because we know that's not accepted.
Yeah, if the last number is every time there is a 0 in the number, we have to go on.
We can skip the number basically.
Yeah.
But we can imagine that this solution is like, I don't know how many. I mean, 15 digits. How do you even pronounce that? The
14
amount?
digits. Yeah,
yes,
trillions
like,
probably.
I'm gonna call it gazillions. It's like gazillions
Gazillions.
attempts. So definitely this is not gonna be the most performant approach. So there must be a smarter way. And spoiler, I know that Roberto already figured it out.
The input of this exercise is like this. So those are the instructions the README was describing before. There are a bunch of them. There will be 14 of them because there are 14 inputs. So there are 14 of those inputs.
Mm-hmm.
You can see the number 2 or 14 up here. So there are 14 instructions of input because we will provide a 14-digit number. And every time, if you see while I scroll, those blocks are always identical. I will show you the Python solution now, except for some small changes. Let's go and see the Python solution now. We have Luciano input. Okay, we will skip it for now. We have also my input. They are different.
Yeah, by the way, the reason why we compared the two inputs is because we wanted to be sure that this assumption was somewhat valid.
Yeah.
Because in Advent of Code, you do a login and then everyone gets a slightly different input for every exercise so that you don't basically cheat by copying other people's results, but you need to re-implement it yourself and test it against your input. So everyone has basically different results based on that. So we were trying to make sure that this assumption where a certain number of instructions eventually will repeat was true for different kinds of inputs. And it looks like it is, but of course we get different values in the lines that Roberto is about to show. So most of the input is the same, except some values that will be different for everyone.
Yeah. So we just have two set of input, but for those two set of input, this code that we will write is working. So lucky us if it's different for somebody else, but I don't think. So analyzing the input, we can see that there are 14 blocks, one for each figure of the number that we need to find, that are almost identical, almost the same, except for some constant that change. And the three constants that change are dividing the z by something, adding a number to x, and adding something to y. In the end, it's possible to come from all of this assembly code to something a little bit more readable in basically manually executing mentally this code. Multiply x by 0 means that we make x equal to 0. So this is x equals 0.
Mm-hmm.
Then we say add x to z. So we are basically saying, okay, x is equal to z. Then we say that x is what we have modulo 26. So, okay, so x is z modulo 26. Then we divide z, so this is on the side. Then we add to x 14, so is z modulo 26 plus the constant. Cool. Then we say, is this equal to w? W is our figure, is the figure that we are processing. If it is equal, it means that x will be 1 or it will be 0. Then we do another equal where x is equal to 0, so basically it's a not.
Mm-hmm.
This is a not. Then we do the same with y. Y multiplied 0 means y is 0. We add 25, so y will be 25 multiplied x plus 1, everything multiplied by z, and we keep the temporary value in z. Then we reset y again. We add the digit that is coming from the input. We add a constant that is changing. We multiply by x, that can be 0 or 1. And then at the end, we sum with z. So all of this reduced can be x is equal to 0 if z modulo 26 plus b equal w. Where is b coming from? These blocks of code are different just on 3 values. This one, and this one. I called them A, B, and C for lack of more fantasy, I think. for lack of creativity. So now I'm using them here to explain. Then z is equal to the integer of z slash a, integer because we have to round down. And then z is equal to z by 25 by x plus 1 plus our input figure plus c, that is this constant here, multiplied by x. Z is this accumulator, basically, that is passed through steps. Y is only used as a local accumulator, so it's not in this reduction for that reason. If we take all the 14, we have 14 blocks with 3 different constants. If we take all of them, we have this. We have 1, 14, 12, 1, 15, 7, and so on. Looking at this input, every time we have a divider that is 1, the second parameter, b, is greater than 9. So if we go back here and we were saying, if z modulo 26 plus b is equal
Sorry,
to
before you get into that, let me just quickly summarize to make sure that we are in line. So basically what you did, you realized that there were repeating blocks in the assembly, let's call it assembly.
Yeah, let's call it assembly.
Except that these repeating blocks, there were only 3 instructions that had some small differences. So what you're basically saying is like, okay, we can reduce all of that code into just those 3 differences, and we have 14 lines, and that's pretty much all the input we need. At the same time, you are also doing a reduction, saying all that code is basically a few mathematical expressions. There you have 3, and it's basically, rather than having 14 instructions, this is like mathematically what we need to do, and it's just 3 steps. And now, if I understand correctly, you are also trying to analyze the input we will have compared to these 3 instructions to figure out if there are other optimizations we can do. Is that correct?
Exactly.
Cool.
Now, we have reduced, like you said, the input basically to a list of tuples. So it's way smaller. We don't have to do all of that. But still, going with a brute force approach will still take forever. So we can see that every time we have a 1, this second number is bigger than 9. Why I say it's bigger than 9? The second number is used here, and it says z modulo 26 plus b must be equal to w. W can only be between 1 and 9 because it's the input figure.
It's 1 digit, right? Because we process one digit at a time.
Yeah, exactly. So can only be between 1 and 9. It's impossible to be bigger. If b is always bigger than 9, and it is, this will always be false.
Right.
For when there is a 1 here. And at that point, x will be 1 if it's false. With x1, what is happening in this line when x is equal to 1 is that the number z is multiplied by 26, and then we add something. This something is our digit plus a number that is a c, that is the third number that is in this line. So when we have 1, we will basically multiply z by 26 and add c and add 12. And then when we have the second line 1, 15 is making x equal to 1, so we will multiply z by 26 and add 7, and so on. The c here is never more than 26. To be honest, it's never more than 12, but okay, 15. There is the biggest one. Yeah. Yours can be different.
Definitely not 26.
But not 26. Because basically what they are doing here is treating z like a stack. It's an integer that is used by a stack. You multiply by 26 and you add a number that is less than 26. Then you multiply again by 26 and you add another number that is less than 26. In this way, this number can go back to the single numbers by doing modulo operation and shift to the right. And the shift to the right is a division by 26. And look, the other operation that we have is a division by 26. Interesting. Instead,
I'm really glad that you are experienced with assembly stuff. I will never have figured out these patterns.
When it's 26, what is happening? We are doing the shift back of the number. But we need to have x equal to 0. Because if we don't have x equal to 0, what is happening is that we will divide z by 26. And being x 0, 1, we will multiply it back to what it was. And we will basically just change, instead of shifting to the right, removing the number, we will just change what is the last element in this kind of stack that z represents. But we don't want that, because we want at the end to have z equal to 0. The only way of going out of all of this with z equal to 0 is that this stack that is represented by z is empty. Because otherwise there will be some number. even in the last step, if you divide by 26 and you come out with 0 because you divided so much that the number went down to 0, but you add the last figure is at least 1. So it will never be exactly 0, z, at the end of the program. So every time that we find a 26, we have to make x equal to 0. In this way, we can shift out the number and we don't add a number anymore, because when x is 0, this becomes 0. I think I write it. Yeah, it's explained here. When x is 1, the number z is shifted the left, multiply, and c plus our digit is added to z. When x is 0, the number z is shifted right, divided. Note that the line, this one, when x is 0, is just becoming z equal to z multiplied 1 plus 0, so z doesn't change.
Instead, so you basically found an early condition, which is a huge optimization, because most likely, most of the time, we can just stop early and not compute everything, right?
Yeah. To have out of our last step z equal to 0, we need to satisfy the condition that makes x equal to 0 every time that a, that is the first number, is equal to 26. So for graphical explanation, simplicity, let's think of z like as a stack. That is what it is. Just we don't meddle with numbers and bits and all this kind of stuff, but let's visualize a stack. The first instruction that I have is a 1, and it tells me to add 12 to the stack. But I will add 12 plus the first digit of the number that I have to find. Then we have 4 instructions that are 1, 1, 1, 1. So we go on adding to the stack, and we have different numbers. We have 7, 1, and 2. So 7, 1, and 2, plus the second digit, plus the third digit, plus the fourth digit. Now we find a equal to 26 and b equal to -5. To satisfy the rule and get x equal to 0, we have to say that 2 plus w4, this is the last element in our stack, -5, that is b, is equal to w5, that is the fifth figure. So that means that the fifth digit is the fourth digit -3. But we know that the digit must stay between 1 and 9. So at this point, w4, so the fourth digit will be between 4 and 9. And the fifth digit will be between 1 and 6. And now we remove the last element from the stack. And we go back to this kind of stack. Going on, after this division, there are another 1 that are adding to the stack. So we go back to having this stack. So 15 plus the 6th digit, 11 plus the 7th digit. Then we arrive to the 8th, the one after the 7th digit. That will be 11 plus the 7th digit, -13. -13 is coming from here. 11 is coming from here. We go down back. So we have that the 7th digit is between 3 and 9, the 8 is between 1 and 7. And we go on like this. So we arrive at the 6th is between 2 and 9, 1 and 9. The 3rd is between 8 and 9, and the 10th is between 1 and 2. Then we go on with other of those rules. We arrive at the end. At the end, we have that the first digit can only be 1, and the last digit can only be 9. So out of those, okay, with the last two rules, we know that to have 0, we have some numbers that can't move a lot. Every rule is giving you a max and a min digit for every possible position. We know that the first one is between 1 and 1, so it will be 1. The last one will be 9, so we have 2 digits that are not moving. And we have all the other digits that can stay between a certain range. Cool. But now, part 1 wants us to give the highest number. Part 2 wants to give us the lowest number. So to get those numbers is enough to take those rules that we have for every single digit, and for the max, taking the max, and for the mean, taking the mean of the rule. So if 11th must be between 7 and 9, for the max number, we will take the 9. For the mean number, that is the part 2, we will take, for the lowest number, we will take the 7, and so on.
So this is basically the trick. Rather than running every possible simulation, we run this instructions by using kind of a generic W, right, for every digit. And we use that to kind of understand what are the ranges for every single digit. And at the end, we have 15 ranges. 14. And with 14 ranges. And with those ranges, we can just say, take the maximum value of the range or the minimum value of the range for every single digit. And at that point, you have both maximum and minimum.
At that point, we have the solution. I have the Python code for that, but this is more a test. I solved this exercise more from the math side than from the coding side. The code is not a lot. The code is just doing what I did manually. So I already have the solution for my input manually. So the parsing is just taking line 4, 5, and 15 that are 0, 1, 2, 3, 4, 5, and 15. So I'm just taking the numbers from those lines. I'm splitting and I'm taking the last number on the right, making it a number. Then I print it just to have it here to check if I got it correctly. And this is my input parsed. Then I have my solution that is creating the stack we were showing before in the solution. Rules are the 14 rules for the figures. I go through all the parameters, keeping I. I is my figure, is a figure 1, 2. In reality, it's figure 0, 1, 2, because it starts from 0. If A is 1, I append to the stack C, that is the number, and the position I found the number. Else, it means that is 26. I pop from the stack the number and the position of the digit I have to work on, because I have to compare I with J, so they are the two digits that go together. My delta will be B plus the number that was in this instruction. If the delta is positive, it means that my current, the bit that comes from the stack is between 1 and 9 minus the delta. If the delta is negative, the number will be between 1 and minus the delta, but being that negative, it means that it's 1 plus something and 9. So this is the rule for the digit that comes from the stack. And the rule from the digit I'm on is the rule for the other one plus the delta that I computed, because like we see here, we have 2 and 13. I will set my J is 2. Sorry, I jumped around. My J will be 2. I set 1 and 2 for this rule. My delta is 7, that is this 7 that is here. And so I will say, okay, then for 13 is 8, 1 plus 7, and 9, 2 plus 7. When I do all of this, I will have filled all the 14 rules that are basically an array of tuples, because they will have 2 values, left and right, a low and a high value. I have my rules out of it that are this is a list of tuples of 2 elements. At that point, this is your solution, by the way, not mine.
Yeah, well, should be the same. The same logic, I guess.
The same logic, yes. I take the max for part 1 and I take the min for part 2. I can run this again to have back my input, because I want to show you that there is also a proof that the numbers that will come out are right when Colab is starting. Okay, my numbers are quite different. Yeah, for example, my max is starting with a 1. Think of starting from all 9 and going down. Before you arrive to this number, you have to parse trillions of numbers, and it's not possible. I made a brute force approach just to check the inputs. This is a way in Python of creating a code from a string. So I'm converting the code in assembly to Python code. So the add is this plus that, the multiply is this by that, and so on. At the end of that, I have a program that is exactly a one-to-one replica of the, here I have all my registers.
You're basically transpiling that assembly.
Yeah, I'm transpiling that assembly into Python with a JIT on top of it just to be fast. I also have this version that is the one that I showed you before with the manually interpreted code. But in the end, this is my input for my output for part 1 and my output for part 2. I tested them and I have 0 with the transpiled one and with the optimized one. I have 0 with the transpiled and the optimized one. I also wanted to see if it was not just always giving 0 by putting in a number made of 14, 1, and is giving something else.
And it's consistent between the two.
And it's consistent between the two of them. So it means that this reduction is working exactly like the transpiled version. And the transpiled version is for sure exactly what we need to do. It's only that it's too slow. The last one here is a Colab that was trying to solve that in brute force with the GPU, but even with the GPU, trillions of numbers to test are too many. And so back to our code. Now we have to do this in Rust,
which is going to be fun. I'm going to rely on your guidance, because I think I understand the problem, but of course I'm not going to remember I understand the solution, but I'm not going to remember the formula directly. So let's.
Well, we are going to translate. In the end, we need a ADQ for the stack and a parser that is taking only certain line of the input.
Exactly. So maybe the first thing that we could do is to write the code that takes the input and gives us the 14 tuples, right?
The 14 tuples of 3 elements, exactly.
And then we need to use them as an input for
For
our
the
ranges.
solution. Yeah.
Well, for our logic parser, whatever you called it, and which is going to give us the ranges. And then at the end, we just go through every single range and select min or max, depending on part 1 or part 2.
Yeah, that at that point we have a common function that part 1 and part 2 will call, and they will just do a different kind of operation on top of that.
Mm-hmm. Okay, so what we can do is, let's do a function, fn parse input. I'm just going to call it for lack of imagination, I guess.
And
So
the Copilot started giving you...
Copilot started to go crazy, and oh my God, I don't even want to read it. So what we want to get in the end is...
Northeast to west. What is telling about?
Sorry, even my laptop went crazy. So it's I32, right? Oh, no, actually, it can be an I8.
It must be negative also, yeah, but I8 is more than enough.
Because it never goes more than 128, right?
Oh, yeah, for sure.
Okay, so
below 26. For lack of less bit,
right,
we have 14 of them.
That's what we want in the end.
Yes.
Okay, so what are we going to do is basically let mute res, and this is going to be all of this.
Can't you write default, try to return res and see if
actually, yeah, that might work. I like how you're thinking. Default, and then we return res, and let's see if it figures out.
Just
it
write,
does.
Or just write res. I don't
just
think
write res. Sorry, I've been doing too much JavaScript lately. Okay. Oh, look at that. It's again going crazy with north, south, or whatever. I think
we are not doing that. That was another exercise of this.
I think it's looking into previous exercises and trying to figure something out.
No, we are not doing this, please.
So what do we want to do? Can we do this
we have to take the lines 18 in block of 18 lines, 18 by 18.
Yes.
And we have to take from this block of 18 line the 5th, the 6th, and the 16th line, and just to take the last number of that row. So we have to take a row with a specific
so what
index.
We can do is for 0 to 14, right?
Yeah.
Is it 14 times, right? Or 18?
Yes. No, 14.
14?
Because we have 14 figures.
Actually, let me do this. We can do let lines equal input dot lines.
You have to collect them to address them with a number. Can you address them with a number like an array, or can't you?
Do we care? I was thinking more to do something like this, lines dot next, until we get to the point where we know we have a value we care about.
Okay.
Actually, I think we can just do lines dot take and say.
Let's say, for example, the first line we have to take is line 4.
Okay, we can do skip. So we can skip 3, right? And then we can do let something lines.
We have to skip 4 because we want the 5th line. We have to skip 4.
We want, okay. But you get the idea, right, where I'm going?
Yeah, okay. Yes. Let's skip 4. Then you take the line and you take the last number on that line. On that line, there will be free stuff. So 2 spaces.
So let's see how that looks like. So we want to get this one, sorry.
Yeah, that one. And we want that one. We only want that one.
So we can split this line by spaces and just take the last element.
Yeah, it's exactly what I did in Python, but in Rust,
Cool. So
when you split, you get iterators, I think, right?
Let's just call this div z because I don't know.
We expect to. So we remember.
So what is it complaining about? Lines needs to be mutable, of course. And then, so at this point we can do div.div z. This is going to be a reference to a string. So we can do split by space, and then we can do last.
Parse as integer.
Wrap, and we can do let val, I guess.
I call it that A in Python, but yeah, val.
Is that gonna work? Yeah. Let's call it A.
Okay, let's keep this A.
So at this point we have the first number. We can do the same thing to get the other B and C, right?
Okay,
and then,
B is the line after this one, so
the line after this one looks as an add x. So let's call it add x is equal to lines. The next unwrap,
and B, unwrap, okay.
And we need to do the same. Let B is the last number that we care about again, right?
Yes.
So this 14 in this case.
Yes.
Okay, so B is an I8, and we do add x, split, last, unwrap, parse unwrap. That should do it. And now, what do we need to skip from here?
We have to skip to write to line the 16th line, so the one where
1,
it's
2,
add the
3,
y.
4, 5, 6, 7, 8, 9.
9. Yes, we have to
and
skip
get
9.
to this one. Okay.
Yeah, and skip 9.
So lines skip 9. And let's see. Actually, no, before that, let's read the line and let's call it mul y. Is this the one we care about?
No, add y, the one above.
Add y, okay. So let add y is equal to line next unwrap, and then c, which is an I8, is equal to add y dot split dot last dot unwrap dot parse dot unwrap. Thank you, compiler. Sometimes you are useful.
Then we have to skip until the next input. So
what do we have left? 1, 2,
1, 2, 2. We have to skip another 2 lines.
So lines.
Let's see if it makes sense. Every loop we have 4 plus 2 plus 9, that is 15, plus 3 line next, that is 18. Cool, because every block is 18 lines. So the math add up. Now, at the end of this, before the...
Let me see why he's complaining here with this next first. Moved value lines. Oh yeah, we don't need to... I think we can just take a reference, right? Can we?
In line 5, we have to take a reference.
What if we just do this? Oh, maybe when you skip.
Yeah, line 5. Line 5. Try to use the reference.
I mean, I could be doing next 4 times. It's just I was hoping there was a better way.
But you can put an end in front of the lines in that line. Still complaining?
No, I think it's the skip method that is implemented as self and not a reference to self, while next is implemented with a mutable reference to self. So let's see if maybe if you take. Let's see what that does. How is it implemented? Again, it's with a self. Okay, so let's do the crappy thing of saying next.
Next. Oh my god.
Next. They're gonna work? No, it's not gonna work. We need to.
It's a 4.
We need to do lines.
Okay, 4 underline in 0 to 4.
Yeah, if anyone in the chat knows a better way, let us know.
There must be a better way. But do a 4. Come on, don't write them.
I'm just going to be very verbose to say.
Yeah, but we have to do 9 times in line 13.
Oh, it doesn't like next as well? How is that possible? What's the problem there? Borrowed value. Wait, so maybe we have another issue here. What is next trying to do? Takes a mutable reference to self. So why is moving the value?
Because in the second loop, probably we are still using the skip somewhere.
Oh yeah, because we need to do it everywhere.
Change all of them, and then we see if there are errors.
Okay,
but
so
please
let's
put a 4 underline around it before I throw up. To 4, yeah.
And we do this.
That is still ugly, in my opinion, but
for
there must be a
lines without moving the iterator. And let's remove this one. And now we can copy this one and do it again here. And we need to do it 9 times. And skip 9. And then we have to do it again with skip 2. Let's see if this makes it happy. It is happy. And it's telling me that I don't need parentheses, I believe, which is nice.
That we just put everywhere. Cool. Now, in the line 4, instead of using an underline, take that variable as an index.
In line 4, okay, I.
Yeah. Now,
which is a U sides. Is it going to be an index for res?
Yeah, it's an index for res.
So it needs to be a U sides. Oh.
So, and in line, we probably will infer it. When you use that in line 23, after line 23.
Can we just say U sides? I was thinking that was the default. Okay, that way, but probably will infer it, but let's see.
After line 23, just do res of that I equal to ABC, yeah, what the copilot is suggesting.
I wonder if now it's going to infer. I'm just curious. I removed a dot, which we might need. It does infer, thank you. And now this res, we are not doing anything with it, right?
We are returning it.
Are we? Oh yeah, we are returning. So why is it complaining? This is not the error. Give me the error. Type annotation needed. Okay, because I think when it gets here, it doesn't know. That's interesting, because here is figuring out the type annotation.
Yeah, it's figuring out the type there. Why? Well,
whatever.
Copy and paste from the return of the function.
Yeah, exactly. Okay, that's good. Here, what is it complaining about? I is used only to index res.
True.
So what are you suggesting? Consider using an iterator.
On top of res.
I'm not sure what it is suggesting.
A mutable iterator. It suggests you to loop on top of res as mutable iterator and then set to the object that we are looping on. But I think for now this is fine.
Yeah, we can revisit this later. I kind of get the idea, but I in my mind this is more readable for the kind of problems.
Or coming from C for sure.
I'm not coming from C, but maybe I should. Okay, so at this point we know how to parse the input. What we can do is to take let, what do we call them?
Parameters. I have no idea.
Parse input. And now we have the params, and we of course we'll need to do the same. Well, we'll probably do a solve, a generic solve, which gives us back the range, but
that gives back the rules, the ranges. Yeah, we can do that and then call it.
Do we need to do a test for this one? What do you think? Can we do a quick test?
Yes, but yeah, parse the input. And if you have the Google Drive, you have the structure that is coming out.
Oh, look at that.
Or do you want me to paste you the Python version somewhere?
Paste. I don't have it open, but I think I can find it. Let's see if I can find it. So what we want to do is let params for sure. Parse inputs, but not all of this. We probably want to check something different.
Yeah.
So I do have, in this project, we have your own input, right?
Yes, so you have to take the one that are executed, the same that are in the explanation, basically.
Exactly. So the values we're looking for are these ones.
114.12, 115.7, 112.1, 111.2. Yeah, exactly those ones.
Okay.
Now you have to do some multi-cursor magic, I think.
Let's try that. No, wrong sequence. This is what I want to do. And now we can do this, I think.
Yeah.
And we want to do this.
And the semicolon.
And that semicolon, and then we'll need to change.
Yeah,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should it be 14? Did I miss one?
From 0, they are 14.
Oh, they're right. They are not 15.
Off by 1 everywhere.
Always.
The biggest enemy of any developer.
Let's see if this works. And it does. Awesome. I didn't expect it to work.
Why?
I don't know. I should have more confidence. Okay, so now we have the params and we know we are parsing them correctly. So what do we do next?
To solve inside part 1 and then make part 1
more generic
solve? Okay. Now we need the queue, the vector queue.
We call it stack.
Yes.
Right? Vec the queue. Yes. No. And we want to do a vec the queue of a known. Yeah.
Is a vec the queue of tuples.
Tuples that are
2 elements. One is C, so it's an E8, and the other one is the index of the rules, so it will be a USide.
USides, okay.
Yeah. Okay, and we also need...
look how I spelled it. Yeah.
Okay.
Typos.
We also need the rules array. That will be an array of 14 rules.
Okay, do we call it ranges, maybe?
Ranges, is fine.
And this can be a 14... Actually, I think there is a range type in Rust.
Oh, well, a tuple of 2 is fine. I don't know if... Like you want, I mean.
Because then we get the min and max.
Okay, and of 14, because there is one range for each figure.
And this will be another mutable thingy. And now is there a default?
That's right.
I don't think there is, because how does it know what's the default range? But let's try.
Yeah, obviously the range doesn't have a default.
Oh, wait, what is it called? Range, right? Do we want the range to be inclusive?
Up to us. I mean, if it's not inclusive, we will. It doesn't have a left and a right. We just need to store two numbers. We are not using the range for loops.
Right, and then in one case we take 0, in one case we take 1. Okay, let's just do tables because it's easier.
Okay.
I8, I8.
Yes.
This has a default because this will be 0 and 0 by default.
Okay. That is not a valid rule. It is not a valid range because we can't have zeros.
Yeah,
now,
but I suppose for our use case, it's fine for now.
Yeah. Loop on top of params, keeping also the index. So loop with an enumeration on top of params.
Mm-hmm. So for I and param,
that will be A, B, and C in params iter.
Can we do this?
Can you?
Is it worth doing this?
If it's possible, yes.
It is possible. Yeah.
Okay, like in Python then.
Okay, I don't know what it's trying to do here.
No, that is wrong. If A equal 1, you need the round brackets or not?
We don't, but again, I've been doing a lot of JavaScript lately.
We append to the stack, so we do stack.append. What is append? Push? What is in there?
I think it's push front.
Back.
Okay. I always get confused. I trust
me too. Me too, but I think it's push back.
Okay.
Tuple is made of C and I.
C and I.
I is a usize, right? We declared it correctly up there.
Yes, and the nice thing is that right now, because they are all 8 bytes, I think all these things are a copy, so we don't need to think about references or stuff like that. Like it's just copying everything.
Okay.
Let's see if I'm wrong with that. Am I?
Complain.
Okay, but we need to explicitly do that because that was a reference here.
I have an ad on Twitch.
You have an ad on Twitch. I don't. Interesting.
Do you want to wait?
Let's wait a little bit. Sorry about that, people. I should have pushed it forward.
Second ad gone. And 7, 6, 5, 4, 3, 2, 1, ignition. Okay. The else of this is popping from the stack.
Mm-hmm.
So we do a pop.
So stack.pop
back.
Okay.
Yes. And it will give back us a number and
what do we call it? J?
No, a number and J. We have two stuff in there.
Oh yeah, so we call it, what do we call the numbers?
The number is a number.
N and J?
Yeah, okay, let's call them N and J.
And we can unwrap because we are sure that there is something there, right?
Yeah, if it's not going to work ever. So. Now, we compute the delta between the figures that is J and the figure that is I, and this delta is equal to B plus N.
B, the reference, does it need to the reference? B plus N?
N, yeah. Do you need to the reference stuff?
Probably not, because this operator is smart enough to do that for us.
Okay. Now, if the delta is greater than 0, so it means that it's positive.
Okay, if delta bigger than 0.
The ranges of J almost is not correct, but almost.
I have no idea how it's guessing this. But...
ranges of J is equal to 1, 9 minus delta.
1,9 minus delta.
Else, thank you. Let's see if he is suggesting. Yeah, correct. Okay. Now I understood. Smart guy. And after the if else, we have ranges of I.
Wait, I have an extra curly brace. After the if else, so here.
No. Inside the else of the first if, but after, okay, there. Range of I is equal to, not 1 to 9, Copilot, go home, you're drunk, is equal to ranges of J of 0 plus delta.
Ranges of J
dot 0 plus delta, comma, ranges of J plus, okay, what Copilot is suggesting. Now
But
it's
we
not drunk
need
anymore.
parentheses.
It's not drunk anymore.
By the way, I see we have WGAFFA in the chat. So hello, how are you? Sorry, I'm not looking at the chat, so apologies if we are slow.
And I was distracted. Oops. Now,
okay.
Out of this, we should have in ranges the possible range of every figure. So from 2. And for part 1, we have to take the max of every range and put all together as a number.
Okay, so what's the best way to do that?
We can do a map. No, sorry, reviews. That is called fold. Okay.
So we can take ranges.
We have to take the ranges. Before doing the fold, we have to take the mean of every element of ranges. The max, sorry, part 1 is the max.
So map, we take A, B.
Take the max between A and B.
Return B.
That will be B. Yes, because we put them in that order. Yes.
Let's just call them min max, and we take max.
Yeah.
And then
now we fold.
We fold. And fold, we have fold. We have only one value, right?
Fold, we need a function to give back a combination, and it takes 2 values. The one
fold takes the accumulator. Which one comes first? Let me.
Don't remember. And the init is 1 in our case.
Is that correct?
More or less, no, but you can keep it and we can change it.
Okay, it takes an init
1
and a g, where g is a function. Okay, starts with 1.
No, ours start with 0, but we just changed it. Yeah. And then it takes accumulator and the value. I don't remember in which order.
That's what I'm trying to figure out. So it's taking accumulator.
Okay, the accumulator first.
And self item. Okay. Yeah. So accumulator is going to be accumulator and current.
Yeah, the figure. So it's accumulator by 10 plus current.
Oh, look at that.
This is what Copilot is saying. In theory, this is the solution.
Okay, min didn't care.
Yeah.
And now what we want to return is res.
Do we have to unwrap something?
As usides. Why this is I8? Oh, yes, because current needs to be as U64. What is going to be?
Yeah, it's going to be a very used number. I think 64 is enough. And you declare line 33, you declare usides, but you can declare U64 in line 33.
30. Oh, yeah. U64. Is that going to be enough? I think here we need to do more. Accumulator as well is a U64. So why is it complaining? Okay, we need to the reference. But this is super ugly, but whatever. Sounds good. Okay, so do we test this solution?
Yeah, let's try to test part 1.
It was fast and it works. Magic. Cool. Good job, Robert.
Now we have to do the same with the min for part 2. So this will become a function that we will call. Rename part 1 to solution and then create a new part 1. This is faster, I think.
You are right. So solve.
Yeah, solve.
And then we copy paste this one and call it part 1. Now the one thing I want to do though,
you just have to keep the fold with the max and everything else in.
Exactly. So here we can have a generic.
What you want to do?
S. And this is S, where S is a function that. What's the syntax for that? I want to have like a generic.
You want to pass a lambda.
This lambda here, exactly.
Yeah, you want to pass that lambda.
So this needs to
I
be
understood
S.
that, but I have no idea how you do that.
How you do that is basically, if we check again fold, you see that fold is basically taking an fn mut. So we want to do something like that. Fn mut and the 2 arguments and the third result. So fn mut, what is the argument that we get?
We get a ban and a min and a max. That are the 2 elements of the tuple.
So map needs. So this is basically what we want. Fn mut self item b, where self item is the tuple basically. So the tuple is E8.
And gives back a boolean. Map wants a boolean.
And gives us back one value, so E8.
Okay, you're right. Map is not filter, is a map. You're right.
Okay, sorry. Now why isn't this one happy? S.
Because you have to declare the name of the variable.
Oh, yes. Selector. Yes.
And then you have to do selector in line 59.
Fine.
Okay.
Now it's not happy.
Oh, it's not happy.
There is a problem with reference. So this will be a reference to a tuple. Sorry, not this one. This one. Is that enough to make everything happy? Cannot be the reference. Why not?
Because map now is not returning a reference. Map now is returning I8.
Sounds good.
We will need to use the star inside
our map, which is fair enough.
Our S.
Okay, so now the only thing we need to return here is basically input can be this. Oh, Copilot, go for it. Solve.
No, nothing. You changed that, and now Copilot is not understanding anymore.
It's quite shy.
Yeah, it's fine, but it's returning the wrong one.
Wait,
but,
this needs to be a U64 and a U64.
It was almost there. It was just taking the wrong one, but.
And yeah, let's just do in max, and we return max. That's it.
Star
right?
max.
Star max because we need to do the reference. Sounds good. And we do the same here, and this time we do min max and return.
We have Minon P in the chat.
Hello, Minon P. How are you?
And rename 69. Remove the yeah.
Cool. So let's see if this works. It does work. Amazing. Everything worked the first time.
And we passed a function as a parameter, basically, to compute the mean or the max.
So I'm going to commit all this stuff.
Yeah. $24.
And we can merge and switch to the other branch. Actually, I'm going to merge later. We know we have another branch with the solution for the 25th day. Oh, Kevago, thank you for the follow. Thank you very much. How are you today? Okay, do you want to explain the day 25 exercise?
Yeah, give me a second that I have to open it.
Okay, take your time and I'll switch to your screen.
Yeah, I have to go to the other pull request. 25th here. Then file changes. Come on, GitHub, you can do that.
Meanwhile, Minompi is telling us that he's always amazed to see us writing code. So I take that you are...
when it works, yeah, when it works, I'm amazed too. Okay, day 25, Cucumber.
Let me put your screen. There you go.
Yeah, okay, sorry. I started reading without. Can I go?
Go ahead. Yes, you are ready.
Cucumber, so part 1. This is the bottom of the ocean trench. The last place of the slate keys could be. Your submarine experimental antenna still isn't boosted enough to detect the keys, but they must be there. Also, we need to. Also, all you need to do is to reach the seafloor and find them. Long story short, we have cucumbers that go east, represented by this charter, and some of them that move south, represented by a V. Each location can contain at most one cucumber, and the remaining locations are empty, that is a dot. The submarine helpfully generates a map of the situation, your puzzle input. For example, this is an example, way smaller than our puzzle input. At every step, so here we are gaining the scenarios of doing steps. In every step, the cucumber that is facing east attempt to move forward one location, and the one facing south try to go down one location. When they move forward, every cucumber in the herd first simultaneously consider whatever is the cucumber that's in the adjacent location that is facing. So the one west go east, and the one bottom go south. And when you have a situation like this, so you have 5 cucumber in a line, after one step, only the first one moves, because the other ones will be blocked by the one in front of them. So they check the state simultaneously in the same moment.
So it's like cars in a queue that you need to wait for the one on top to move before the second one can move. And so
then at the next step, the first one moves again, because again, he has nothing in front of it. And the second one moves, and so on. When there are east facing and south facing, the situation works like this. After a single step, the cucumber moves to the right, so east. And in the second phase of the step, they move down, obviously, always if it is empty. So starting from this configuration, the first half of the step, this guy moves right, so it goes here. And this guy can't move because there is a sea cucumber in front of him. The second phase of the first step, the one that are facing south, this one can go south because when it starts, this one is not there anymore. So every time there is a step, basically there are two steps, phase 1 and phase 2 of the step. So this one can go down and down, and this is still in the same position because it's not possible. Due to the strong currents in the area, the sea cucumber that move off the right edge, they appear back on the left edge. So it's like Pac-Man. When somebody is here, it teleport here. So they roll back to in the same line. There is nothing blocking them. Here we have a bunch of examples of how everything moves. A lot of examples. There is a moment, because of the input, where there isn't possible to move anymore for any sea cucumber. For example, after 58 steps, our input in the README can't evolve anymore because all the one going right are blocked and all the one going south are blocked. So this is a state that is not evolving anymore. Find somewhere safe to land your submarine. What is the first step on which no sea cucumbers can move? In the example is after 58 steps, in our input was 5 or 7 steps.
Perfect. So this is another simulation exercise where we need to build this model, run it until it blocks, and keep a counter, and then we return that counter, right?
Yes, exactly. Our input is this guy.
Beautiful.
Is 138 by 137 lines, dots, I think. And now
Is it square?
No, it's not. Is I think 138 by 137, so it's a rectangle.
Okay.
So we need to keep our solution not square. Let's open the Python solution for this guy. Come on, you can do that. Okay, this is the input of the README. This is the full input for this exercise. And this is the Python solution that is giving 4.7. How this is working? Like the game of life that we did multiple times, that is on an infinite map. I keep a set of coordinates for the sea cucumber that are facing south. I keep a set of coordinates for the sea cucumber that are facing right. I parse the input. So for every row, for every character in the row, if the character is greater than, then I add to the set that points right. Then otherwise, if it is a V, I add to the set that is pointing down. If it's a dot, I do nothing. This is X and Y, capital X and capital Y are the size in X and Y of my board. So when I parse, I also give back the size of the board. Then I define a function that is doing one step. The step takes the one that are moving right and the one that are moving down. I keep a Boolean change to tell me if there was any movement in this state. If there was any movement, I set it to true. Otherwise, I leave it to false. And I return the new set of sea cucumbers that are going right, the new set of sea cucumbers that are going down, and if they moved at all. Loop, I loop while loop is true. I start from 0. At every loop, I do a +1. And I loop only until there is a change returned by the state, by the step function. And I go on like this until this will be false. And at that point, I'm exiting. And my counter, is 507. I also did this with the, and this one to run in Python takes 2 seconds, more or less. I did this also, if I find it. I'm not finding it. Why am I not finding it? Second, year 2021, exercise 25th. But it was somewhere, it was just blind. I did this also with the GPU because this is a very parallelizable problem in theory. And with the GPU, is a little bit more of code, but I have a GPU move to the right, a GPU move down. Every step I call both of them. And then I have zeros that tell me if there was any change. Basically, I spawn one worker for every cell of the map, and they work all in parallel. So I have 137 by 138 cells. And here I'm spawning, where is it? Yeah. There is the while true, the +1, and my step become this. So Go right, shape is the shape of my input with one thread per worker, but that is not important. We are not super threading here. And do the same with the one that go down. And this solution is taking 0.166 seconds. And is giving back 407 too, because 507, sorry, because obviously the result must be the same. So way faster with the GPU, because this can be done everything in parallel. Every cell can be a different parallel thread or whatever. Ready for Rust?
Yes.
Are you ready to Rust?
We are ready to Rust. Shouldn't be too difficult. We have done this kind of advent of code type of things multiple times. So let me just switch the screens. So this is our scaffolding. So, okay, let's start by defining the grid. I guess we can do a struct where we will have width and height, right? Grid. And this struct, actually, we'll need to do a cell first, which can be an enum of left.
You are going, which approach are you taking? Are you making a real grid materialized?
I think so, because I think it's quite dense. So, and we can probably keep it all in the stack, right? If it's all materialized, rather than just allocating every single time we want to add an item in an hash map.
Okay, let's try that.
Let's see. If it gets too complicated, we can revert to the hash map. And
day 25 is only part 1. There is no part
2. Sorry, WGAF is saying that we are dropping frames. I hope that now it's better.
Sorry?
I think I am dropping frames. Hopefully now it's better. I think I had some connection slowdown. So I'm just going to repeat everything I said. Basically, what we want to do is we want to have 2 variations left and right. And this is a cell. And then we want to create...
the cell can also be empty, but we want to have...
Sorry, this is going to be const w size, const h size. And we want to have cells, and every cell is an option.
You do with option in the case of the dot.
Yes, that's what I was thinking. Does it make sense to you? And we can derive debug and clone, because probably we'll need to clone at some point. And why it's not up here? I'm probably messing up with the syntax. I'm quite sure this is how you write it, isn't it? Or maybe this goes on the right side. It does go on the right side, yeah. Okay, thank you. We seem to be better now. Let us know if you still see dropping frames. We'll try to repeat whatever might have been missed. Okay, so at this point we have the grid. We'll need to pass the input. And
yes.
Okay, so one thing that I'm going to do is implement from char for cell, and basically what we want to do is, look at that, almost closed. And I think it's actually right. It's just that I am tired and I'm doing stupid things.
No, it's right and down. Yeah.
So this is right. Actually, let me do. How do you do the arrow down? I'm just going to copy it from here.
It's a V. It's not an arrow down.
It's just a V, right? Good catch. So this is down and the other one is right, and then it's just going to panic. And Copilot is helping us a lot there. Then what we want to do is implement from str for grid. And to do that, we need to do const w usides, const h usides, and then for grid wh. From string, we need to import it. Standard, yeah, that's the one. And then we want to implement missing members. So type error, as usual, we are going to ignore any error. We are lazy. And now we need to do this logic here. So this needs to return a grid. Oh, let's see how smart it is. Okay, it's creating an array of cells where everything by default is none. The width is W and the height is H, right? So that seems correct, the first line. Then what is it doing? For every line using the index Y, yes. Then for every column, it does sum into, okay, this is slightly wrong because we'll need to check if it's a dot, it's a none. Otherwise, it needs to use the into.
Yeah, but is
It's very close. It's just this sum here. So
Yeah,
we
it's
can take everything.
initializing the shell with known. So in the end, if we are not able to parse this character,
No, this is gonna fail. This can panic if it's a
that will panic. Okay.
So what we can do is basically.
Can't you say? No, you can't up there. Okay.
I don't know if there is a smart way to do like a map. I know when you do like filter map, you can easily. I don't know though, because I think when you panic, you will need to return a result or something.
Okay, let's say that if he's a dot, you put a known.
Yeah, I think what wGAF is suggesting, it makes more sense. So maybe we can keep it as a suggestion for later. Like implement a try from char, and try from basically allows us, rather than to panic, to use a result and say, okay, your error. Then when you have that, I think here you can use some macro to say try from that.
But let's go with a match. If he's a dot, we leave the known.
Yeah, for now let's do that, and then later we try to refactor it. So match C, and basically what is this? Is basically if it's a dot, we return none. Otherwise, we just
otherwise
some input.
At this point, if there is something else in the input, it will just panic.
Okay, now why is it complaining here? The try bones. Oh, it needs to be copy as well. Fair enough. And we can copy because this can only have 2 values, so probably it's using a few bits to start this one. Cool. So that should give us the grid. I don't know if we want to try to do a test.
No, it's a huge grid. But
we can try the sample one, right?
The sample one? Okay, but I don't know the size of the sample
example grid. We can probably guess it. Let's see.
Oh, we can count it. But
the README part 1, there it is. So in terms of width is, where is it?
You select the line, it will tell you how much charter you selected.
Where?
In theory, my VS Code is telling that on the bottom.
My one is not giving me that.
Your VS Code is different. Okay, count by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Oh, there you go. Line 24, column 11. So 11 columns, right? Which means
10. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9.
And this
1, 2, 3, 4, 5, 6, 7.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 rows and 10 columns, right?
Yeah.
Okay, let me copy all of this, and we can do let grid. It's even trying to simulate stuff there. Grid. The first one is width, so 10, and height
by 9.
And what we want to do is input parse, and input is let input equal this.
And what about the indentation?
Back.
Okay.
Yeah. And now input parse. Why doesn't like it? Oh yeah, this needs to be a wrap.
Okay.
Semicolon. And then I guess.
Well, cell 00 can we assert that is a known?
Yeah, I'm wondering if you can just compare an entire row.
Don't know. We can assert a couple of cells for now.
If we do this and we do.
We have a known, comma, down.
Wait, can I do here use cell asterisk? And now we can just say down. So the first one is down, ... so none.
Down, known, right. Known.
2 right, yeah.
2 rights, yeah.
And then
none. 1 known, 2 down. That known is written nonde.
Good catch. And then we have
2 down.
So another down, and then what was the last one?
Right, I think.
Right, yes. So right. Okay. Why it doesn't like that? Because I need another parenthesis. Ooh. Now why it doesn't like it? Okay, option cell are not comparable. Oh, that's annoying.
Because you have to the enumeration, you have to do something up there.
I think it's just that some, like the optional is not comparable.
And so you can't even assert on the single row.
Let's do something like this. let expected first row equal all of this, and remove this. Right, and now we can do for is that what we want? For X and cell in expected first row, and we compare. Okay, there are suggestions here in the chat. It is if contain type is comparable. Oh, you're right. Okay, then let's do that. Thank you, WGAFA.
We have to derive the comparable.
So we need to derive EQ.
Partially Q.
And partially Q, I guess. Maybe just partially Q would be okay.
Go with just partially Q. Oh, well.
Let's just go with partially Q and see if that's enough. So let me actually
Assertive.
Let me revert because it's probably faster. Okay, that was it. And then we wanted to add EQ or partially Q. Yeah, that's enough. Thank you so much.
And is also green.
It's not. I don't know if it's green. Let's test. It is green. Cool. Do we trust it, or do we want to check line 2 as well?
I trust it.
I trust it as well. Okay, so and it's not exploding, so it's able to get to the end without like out of bounds type of things. So I think we can trust it. Okay.
Now let's define a step function that takes a grid and gives back a grid. And how do you detect that the grid didn't change? Do you want to implement the quality on top of the grid, or do you want to have from the step back a
number of changes?
a Boolean yes or no? We don't care.
Oh yeah, even that. Yeah, let's do it simple this way. So let's do fn step. Fn step now needs to be generic. Actually, we can implement it in the grid. It's probably easier. So implement const w usides const h usides, and then grid. Not get. We don't care about get. Fn step, and it takes a reference to self and just give us back another self. Right?
And a Boolean.
And a Boolean, so good point. Okay, so let mute changed equal false, and let mute new grid equal, let's do, what do? We do, okay, if we just do self, is that going to be enough? Default. And we probably...
Seems fine, I mean.
I think that's fine. And now what we return is...
new grid command change.
Okay, now default doesn't work because... Can we implement default?
Can we derive default, you mean?
I was wondering, because I mean, if it's an option, I was wondering if the default was just none.
Mm-hmm.
Let's see. Come on, what's the error? Tell me the error.
Default is not implemented for grid, so it's grid that is not deriving stuff.
Okay, yeah, you're right. So here we can just say derive
default.
Is that gonna work? Can you do it?
So Vue is not satisfying default downstream.
I'm not too sure what. The following other types implement the trait default.
Try to add the default to the cell. To be honest, I don't think it's that. But
yeah, because it doesn't know like which one to pick.
Yeah, it doesn't know which is the default of the shoe. Okay, let's create manually.
Can we do something like this? Work?
You are a little bit too advanced.
I'm too ambitious. Yeah. Okay.
You can do default on another line. You see there in the comment. Add the dash the comma default.
Sorry, why are you implementing? So default, and then
go in the over. It says.
Oh yeah, so we can do here
maker.
Something like this. Okay, that now this one has default. It's still complaining here. What's the problem?
Okay, so it's the option that doesn't have default.
What's the problem there? The trait bound option cell. The following other types. No, I don't understand this one.
Okay, let's not use the default in the initializations becoming.
Is it because we have a default there? No. Okay, I don't know. Maybe because we have const generics. But what we can do is to do something super crappy and do a new function, right? Which gives us a perfect.
Self new? No.
Is that gonna work if we just do this? Yeah. It figures out that the parameters are the same. It's never used. It is used here. Oh, because we never use step. Cool.
Okay.
Okay, so what do? We do, now we need to
At every
simulate.
step, we have to do two stuff. The first one is going to the right. So for every cell that is a cucumber facing right, we have to see if the cell on its right, or we have also to go modulo
Yes.
W, because we have to go back to 0 in case.
So
is empty.
for every row first, so for every y in
0 to h, yeah, makes sense.
Okay.
For every x in
0 to, I'm almost tempted to accept all of that. What is it doing? So if there is a cell, that cell can be either right. Okay, then it's guessing something wild. Let's do it ourselves. Okay, so if there is a cell, so that part we like it, which is equal self.cells, y and x.
Okay.
At this point is where we have the logic.
Now we have only to look in this loop to the one going right. Then we will have to look to the one going down.
Why do we can do it in the same loop or no? It's just
no,
it will be
because no. If this was my first error when I did it.
Okay.
They don't move in the same moment. They move first the one going right, then the one going down works not on the grid that is passed by, but on an intermediate one.
Oh, okay. So the ones so everything moves to the right, then in the same step you have an updated state, and then you move everything to the bottom.
Down. Yeah. So we need probably also a new grid. We also need an intermediate grid.
Okay. So what we can do here is basically right, I guess. That should do it. Oh, sorry.
Okay.
That will be
Some
cell,
cell colon
right.
colon right. Yeah.
Okay. So this is basically if it's moving right, doesn't matter.
Now we have to look at what is right.
Okay.
We have to say, look, try to keep it, but it's wrong because it's also doing the second part.
So let's do
Can you
one
keep
next cell.
Yeah.
And it's going to be this one plus 1, but we also need to do the modulo W, right?
Yeah, put x plus 1 in round brackets because the modulo is
point.
Yeah.
Okay, this is
so
going
that
to be
is the next cell. Okay. If the next cell is empty, so if it is known,
if
next cell equal known, don't listen to
is known.
Okay. If the next cell is known,
then it moves.
Yeah, it goes in the new grid. We need the intermediate grid. We need a grid before the new grid.
But can we just mutate this one or not?
No, because it's a mess.
Okay.
We can try after to do a mutation, but it's more complicated to think about.
It's going to call it final grid then.
Yeah, final destination.
And this is final destination.
Now, in that if the cell is known,
it moves to the right. Right?
Intermediate grid, yes, intermediate grid of all of that. This is correct.
It looks correct to me. So it's basically saying it goes to the next line, considering that it can loop around, and it's some cell right and changes through. Otherwise, it just copies it. But here it's copying it in the final grid. Should be the intermediate.
No, it's going it must go in the intermediate.
Okay, so almost
Copilot, almost good. Okay. Also, we have to if it is not, the else where you are now, else, we have to copy the value to the intermediate grid otherwise.
Yes.
Yeah, that one.
Cool. Okay.
Now we have to do another loop.
I'm just annoyed by the inconsistency, so I'm just going to do this.
No.
Oh, yeah, you need to copy it and change. You're right.
Yeah, you have to copy whatever it is. There can be a dot, so a known or a down, but you have to copy it, whatever it is. Yeah, copy the cell and change it. Now you have to copy the for loop, the two nested for loop, line 53 to 68.
Yep.
And do the same from
moves everything right first,
and then moves everything down
grid, and then moves everything down into the final grid. Right?
Yeah.
Okay, so let's figure out this code. This is the same. Now, if some cell is down,
the next cell is y plus 1 modulo the 8. So x stay x. There is plus 1, round brackets, modulo the h, that is our 8.
Modulo h. And this one is just x.
X. Do the same. Now is the not on. It's not self in line 74, sorry.
Line, this one.
74 also.
74. Okay, this is intermediate grid.
Everything that is self becomes intermediate, and everything that is intermediate becomes final.
Right. So this becomes
that's final.
And this becomes final, and this becomes
final. And
we need to update this one as well.
Line 84. Don't miss that self in line 84.
Oh, good point.
Intermediate. Okay.
And now, this one needs to be updated as well.
Copy that to line 77. And it's not some right, but it's some down. And also some down in line 80. I think this is everything, to be honest.
Okay. So now, if we need to do something, it's basically let mute counter equal 0.
Yeah.
And then while. Oh, is there a do while in Rust? There is. And what we want to do is.
There is not a loop because we will break when changing.
Loop. Yeah, it's probably easier.
We will break when changing this code. Plus equal 1.
We do that at the top, though.
Yeah, at the top. Then we do the step, and then if it's unchanged, we break.
And then we say, "Oh yeah, we need to create a grid first."
We do that at the bottom. But well, we can have an off by 1 error. We will fix it.
Actually, it doesn't have to be a grid. Let grid, which initially is. What did we say was the input?
138 by 137. Try with that. If we explode, it's my fault. 137.
This is input without an underscore. Input.parse.unwrap. Cool. And now what do we do is, yeah, I like that. And then if not changed.
Not change the break. I'm thinking if the counter plus goes at the bottom or at the end. I think it goes after the break.
Okay, so we increase only if it didn't change.
Yeah, but do you have plus in Rust?
I thought we did, but probably I'm wrong.
I thought you wouldn't have.
Okay, and we return
counter. But that new grid is not good. It's not right. You have to, to assign back to. Okay, you do that in a new line.
Does that work? I think, yeah, okay. Yeah, otherwise I think it's just gonna shadow, because I think this is just a let assignment. Yeah, so this will reshadow the previous one. Instead, we want to make sure that this one gets replaced, because this is. This is the one we use here. Otherwise, we would always loop on the first one.
Let's see if it works. I am not completely sure of that shadowing, but we can.
It did explode. Okay. Finally, we get an error.
Where?
Index out of bounds. The len 138, but the index is 138.
So is 137 by 138. Go in the input, please take a look how many lines we have.
So lines is 137. So the width was plus
The
1 or
width-
minus 1?
It was plus 1 in theory, but what is first, a width or height? Is WH or HW?
I don't remember. That width is first and h is later.
Check the width. At this point, the width can be 139 instead of 130.
140. So 139.
Okay, so it's 139. Why 137? My fault. Off by 1. Almost there.
Let's test again.
Okay, let's see if we have another explosion.
Amazing
Yes,
explosion.
what?
Oh, it said that it did 10 loops rather than 507.
Okay, this is a problem.
Okay, and now we have to debug.
Yeah, what's happening here, guys? Let me look at can only be our step function. Okay, let's start with the first loop. The first loop say this is the second loop.
There you go.
Global. Yeah. If the cell is right, the next cell is cells y x plus 1 modulo w. Okay, that makes sense. Next cell is, if the next cell is known, you go to the next cell with some right, you are changed, else you stay where you are. And the other two types stay where they are. Go in the other one. Let's see if we replaced all the self with the intermediate. If next cell is known, the final grid is the cell sum down. Change it to true as the cell is whatever it was, as the final grid is the intermediate grid. Everything seems fine to me.
You know what we can do? We can implement toString for the grid and simulate the steps of the example.
Oh my
and
God.
write a test for that.
With the example. Oh, try to use the input from the example that you already have in that test.
Yes.
And see what result we have.
Okay, so let's copy this test, basically.
Yes. Until there, yes. Also the let grid, because that grid is 125. Is like 125.
Good point. And basically what we want to do is do this thing, the same thing we did here.
Where are you?
Counter. Right, and then we assert on the counter. We know what's the expected in the example.
Yeah, it's written in the example. Let me see if I find it. If GitHub is helping. Scroll. 58.
Okay, and this
obviously, I suppose, I hope that this one is fading, because you have to change the name of the function, probably.
Cool. We don't need to use cell because we're not comparing that. This needs to be mutable. For some reason, disappeared. Cool. Let's run this. And this is exploding because it's stopping at 6. So I will say very quickly, let's implement a toString for this one. Is it toString? I don't remember how to do a toString in Rust. Let's check. Yes, there is a trait toString for cell. And is that what we want? If it's right, it's this. Okay. And then can we also implement it for option?
WGAFfer is suggesting display. I don't know if it makes sense for you.
Oh, yeah, you're right. That's how you do it. Correct. So let's implement display for cell. Yeah, and that's what we want. And then implement display for option. I'm curious if we can do this. If we can do this, it's amazing. Can we?
Boom. No, it's working.
I don't know if we can do this. Let's see. Give me the error, please. Only traits defined in the current crate can be implemented for types. Okay. No, need to implement display for option. It's implemented for you when you have display on cell. Perfect. That's a great suggestion. Thank you so much.
How do we output a dot?
Oh, that's right. How do we output a dot? Yeah. Okay. So let's just do one thing. Let's just do let's just do it here. Doesn't matter. Let's just implement display inside the
Grid.
grid itself. So here. So implement display and all of this for grid WH. Now, give me the thing. Let's see if you're smart enough, Copilot. Okay, so it's doing a loop for every row in cells. For every cell in a row, if this match the cell, if it's none, it's a dot. I like it. If it's some right, is a right. If it's some down, is a down. And then right line.
F. Because F is just
yeah, it goes back one line
to the new line.
That
okay,
looks good.
Makes sense. Try to print it.
Okay, so let's try here before
at every step. Yeah, before the step.
It explodes.
So
let's just
the
do
loop,
print ln of
grid.
Grid.
Yeah, do that inside the loop, so we have all of them. No.
Oh, good point. Yes, we can see where it
also
explodes.
print line. To also print line of 3 or 4 carriage return after the graph. /n///n.
Let me do one thing.
Curly.
/n/n and another /n, and we can print counter.
Okay.
Right?
Yeah, try.
Let's try this.
Let's see what we have. Let's try to understand what we did wrong. Ah, nice.
Okay, wait. Part 1 is okay. Then we are basically losing stuff, right?
We are losing a lot of stuff. Why? Suicide.
Did we mess up the modulo? Maybe we override stuff.
We messed up. No, they go. Okay, they die badly.
Basically, they just die and then nothing else moves.
Yeah,
okay, that's not what we want.
Let's go back to see what's happening. Oh my god, this is funny. Do a print between the two loops.
A print. Oh yeah, in the
print the intermediate.
Yeah, right.
Yeah, print the intermediate grid.
I like it. Where is it going?
Open curly bracket, closed curly bracket. Yeah, thank you.
And intermediate grid.
Intermediate grid.
Let's run this again. Test example. Okay. So intermediate grid. Intermediate grid looks sane.
No, it's not. It's not. Look at the first line of the intermediate grid.
So the down. So these ones needs to be moving, right? So there are 3 dots here and there are 3 dots here. Now this one cannot move because there is 1 here blocking.
And it's fine, but that one moved and disappeared instead of moving. Okay, so let's check. Where do we write that?
Yeah,
when it goes right.
Very good catch. Intermediate.
Because it disappeared instead of being written in the destination.
Okay, so it disappeared because, let's see.
Line 75. Why it disappeared?
75. So we are saying it needs to stay in the same line, so it's a wider. And then it needs to go to the next one, modulo width. That seems correct to me. Right?
Go above, scroll up. Okay, intermediate grid is empty, it's full of known. So if the cell is, if let some right equal, it means if the cell is a right?
Yes. And it did change it, like it did detect correctly. It's just that it's disappearing.
Yeah, instead of moving, they disappear. And the other, otherwise, okay.
Let me run it again.
Yeah, all the one that moved disappeared.
Let's exactly, that's what I wanted to check. So the ones that are going to move here are definitely this one.
On the line below, the one pointing right, the line below, that disappeared also.
This one, right?
That's disappeared.
And it becomes just a dot.
Yeah.
Okay, and then this other one. should have been moved here. So line 3, position 2 is disappearing again.
Oh, yeah, I understood why. Oh, God.
Okay.
I know why.
Illuminate me. I don't know.
Because when we move it to a specific cell of intermediate that was empty. But then in the else, in line 80, we copy the dot that we will find on top of it. So
in line 78?
No, line 78 is fine. It stayed there. The line 80 we have to change the else in line 80 to an else if it was a down.
If it was a down.
If cells of YX was a down.
Okay, I see why.
Or
here we just say some X.
Wait. Remove the tails, line 80. Remove the tails completely.
All of it?
Yeah, all of it.
Just like this?
Yeah, you have to. No, remove the wool block. Leave also the closed. Yeah, keep the closed curly bracket, otherwise it explodes. Do the same in the other loop.
Okay.
Aside that we can do 2 Ctrl Z and get. Try now. Try now. No, it's not going to work.
So now they are moving correctly, but of course we are not propagating the ones that don't move. That's the thing that we are missing.
Yeah, exactly. Okay, so go with 2 Ctrl Z back to the 2 else's. Yeah. Now do the else if is a down. If let some cell down equal to self.
This one?
Yes. And do the same in the there for the right at this point.
The grid, yeah, that looks correct.
Let me just see if it's the right grid. Sorry. One is a self, the other. Okay. So sorry, was just checking.
Okay, Copilot seems to have been smart enough this time. Let's see if we are smart enough.
See if we have.
Still exploding, but I'm curious to see the.
57 is off by 1 now.
Okay, this looks a little bit healthier. Okay, so it's an off by 1. We gave a 57, and we are expecting
we need to increment before at the start of the loop, before the break.
That's fair.
That we said before or after.
Okay, let's see if this passes. It does pass. Let me remove all the println.
No, this one in this test you can keep them. Remove the one in the step function, otherwise it will print forever.
Okay, it's just that it's gonna print a lot. I mean,
but that is a test. Who cares?
Cool. Our CI is gonna care, but we don't pay for it, so it's fine. Intermediate we definitely want to get rid of.
Okay.
And now this one needs to change as well.
In the beginning of the loop.
Yep.
Or we start at 1, but it's the same.
Okay, let's run everything.
And now it works.
It works. Cool.
We were putting the known on top of the one that moved the right, because before it was a known. So we were saying, okay, you are a known, you go in the new status, in the new state. But it's not right. If you are a known, you go nowhere.
Yes. Yeah. Good point.
You are not important. You're important only if you are a down.
All right. I think we are close to what? Well, more than 2 hours of stream, which is probably our record.
Close to close.
So
we are close to close.
Exactly. I'm just gonna let you close as I do the commit, and we'll merge these changes later.
Okay, let's wrap it up. You can find the recording on YouTube. The link is on the Twitch channel in the About session. If you are watching this on YouTube, we do live streaming on Twitch every Monday at 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave comment and open pull request. The repository with the code is on GitHub. Everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the best ones, but they work often. If you know better ways of doing stuff, please open a pull request, tell us what to do. Thank you for all the suggestions in the chat. There is also a question in the chat. Can you explain why now is working? Basically, before we were going right, we were moving the stuff in the right place, but then in our 4 through the matrix, when we were finding known, we were copying known in the next state, and that was overwriting all the moving cucumbers. So when we find a right, we write the right in this position or in the next one. And if we find a down in that first loop, we write the down where it is. But we don't care about knowns because the state starts with all known in it. Then we do the same for down, not caring about right, just moving the one down. And at the point it was working. Are we going to rate somebody?
Yes, we are going to rate TJ, who always does crazy Vim stuff, sometimes Rust, sometimes Lua. So I hope you're going to have fun.
So thank you. Bye. And see you next time.
Bye.